Hello guys, I Dipali Ponikar welcome you all in this video. In this session I am going to explaining about a welded bracket connection. Okay, first this welded connection is subjected to the direct shear. First for the direct shear, that is or you can say that direct shear stress, or second is for the torsion, or you can say that shear stress due to twisting moment. Stress due to twisting moment. Okay, basically what means the welded bracket connection? The bracket connection consists of two bracket plate. As you can see here in this diagram, bracket plate welded to the flange of steel column. If load W be applied to the bracket, a load P equals to W upon 2. Okay, is transmitted to each bracket plate. The line of action of load P does not pass through the centroid of a weld groove. Okay, as you can see here in this diagram, this is the bracket plate and this connection is called as a welded bracket connection. Okay, and this distance is the center distance up to the load, that is E, that is the eccentric distance, and this load is applied load. Okay, in this topic I have one numerical which is based on the welded bracket connection. So let's move toward the numerical. As you can see here in this diagram, the load P, that is the eccentric load acting over the joint, that is, or you can say that the factored load which the joint can transfer through the flange. Okay, the numerical is like that. A bracket plate is used to transfer the reaction of beam to the column flange as shown in figure. The bracket plate is connected to the column flange by 6 mm fillet weld. The size of fillet weld given is denoted by S, that is the 6 mm. Okay. Well, compute the maximum service load that can be placed over the bracket plate at a distance of 75 mm. As you can see here in this diagram, this distance is 75, that is a eccentric distance. Okay, sorry, not eccentric distance. After calculation, we get the eccentric distance from the flange of column section. Okay, this 2P means the total load transmitted by the bracket connection, that is through both the flange. Okay, and the this is the ISHB 300 at 576.8 Newton per mm. With the help of this ISHB, we get the value, that is gauge distance also with the help of steel table. After that, the first step for solution is throat thickness of weld. Firstly, we have to calculate the load distance. Okay, we have to calculate the load distance, that is a P, or you can say that the service load or maximum service load. The first step is throat thickness of weld, that is a T. The formula is like that, 0.7 S. The value of S is already given, that is a 6 mm. 0.7 into 6 is 4.2 mm. Okay, the throat thickness is 4.2 mm. After that, the second one is length of weld. which is denoted by LW. From figure you can say that this is the L1, that is 200 mm. This is the L2, that is also 200 mm. After that we have to locate first the centroid, that is a G. So we can calculate the value of theta also, that is the theta, and this is the R1. Okay, we have to calculate that x bar also. This x bar plus 75, you can say that this is the eccentric distance. Okay, firstly we have to calculate the x bar, then only we can calculate the value of eccentric distance. Okay, length of weld is L1. This L1 is the parallel side is also L1, so we have to multiply it with the 2 plus L2, 2 into 200 plus 200. After calculation we get 600 mm. The length of weld, that is LW, equals to 600 mm. After that the third step is area of weld, that is AW, equals to the formula for AW, that is the area of weld, is length of weld LW into T, that is the throat thickness of weld. As we are already calculated this, so both the value, that is a T, 600 into 4.2. Okay, after calculation we get a 2520 mm square. Okay, after that we have to calculate the fourth step, that is for centroid G of the weld group from right edge. We have to calculate this centroid, that is x bar, from the right weld group from the right edge. Okay, the fourth is centroid G of the weld group from right edge. Okay, the x bar equals to L1 into L1 plus L2 upon LW. Okay, we know the value of L1 is 200 into 200 plus 200 upon 600. We can calculate the value after solving this, 133.33 mm. The x bar equals to 133.33 mm. After that we have to calculate the Ixx, that is the moment of inertia. For first diagram, that is for column and for beam also, this is the L2 and this distance is T, that is the throat thickness, and this is L1 and this is T. Okay, with the help of this two diagram we have to arrange the formula, that is 2 into, or we have to apply this formula, L1 into T cube upon 12 plus L1 into T into L2 by 2 whole square plus T into L2 cube by 12. Okay, after putting these values, that is L1 equals to 200 into T is 4.2 cube upon 12 plus L1 is also 200 into T is 4.2, 200 by 2 whole square plus T is what? 4.2 into 200 cube upon 12. After the calculation, Ixx equals to 19.602 into 10 to the power 6 mm to the power 4. Okay, and the next we have to calculate the sixth one is Iyy. By 12 plus L1 into T. This is the formula which is required for the Ixx. For the calculation of Ixx plus L2 into T cube upon 12 plus L2 into T x bar minus L1 square. Okay, after putting this value, that is a 2 into 4.2 into 200 cube upon 12 plus 200 into 4.2 into x bar is 133.33 minus 200 by 2 whole square plus L2 is 200 4.2 cube upon 12 plus 200 into 4.2 133.33 minus 200 whole square. After the calculation we get Iyy equals to 7.466 into 10 to the power 6 plus 3.7349 into 10 to the power 6. We get 11.2 into 10 to the power 6 mm to the power 4. Okay, this is the value of Iyy and this is the value of Ixx. After that we have to calculate the polar moment of inertia of weld. Okay, this polar moment of inertia of weld is denoted by IP. Ixx plus Iyy. So we can calculate it then 19.02 into 10 to the power 6 plus 11.2 into 10 to the power 6. Okay, so IP equals to 30.8 into 10 to the power 6 mm to the power 4. Okay, after that we have to calculate the value of the 7th step is this IP is from 7th step and this is the 8th step, that is R equals to summation of x square x bars plus L2 by 2 whole square. Okay, after putting these values, that is the x bar equals to, we are already calculated, that is 133.33 whole square plus L2 is 200 by 2 whole square. The value is 166.66 mm. R equals to 166.66 mm and this is the value of IP. Okay. With the help of x bar, we can calculate the value of eccentric distance. X bar equals to 133.33 plus 75, so we get 208.33 mm. Okay, after that the 10th step is cos theta. We know the theta and this is the r. Okay, this distance is x bar. After that this is the opposite side and this is the adjacent side. The cos theta equals to adjacent side upon hypotenuse. So adjacent side is x bar upon r. We know the value of x bar 133.33 upon r equals to 166.66. Okay, we get a 0.8 cos theta equals to. After that the 11th step is for moment. The load into perpendicular distance, that is a p into eccentric distance. We know the value of eccentric distance but we don't know the value of p, that is a direct shear. So 208.33. okay, the moment is 208.33 p. okay, in the form of p we have to calculate the moment value. Okay, after that the 12th step is direct shear stress, which is denoted by q1, p upon adjacent sorry the q equals to p upon aw. That p is, we don't know, the value of aw is 2520. okay, in the form of p we have to calculate the q1 also. okay, 3.968 into 10 to the power minus 4 p. okay, after that the 13th step is q2, that is shear stress due to twisting moment q2, m into r upon ip. okay, we know the value of moment, that is a 208.33 into p. R equals to 166.66. okay, and the ip is 30.8 into 10 to the power 6. okay, after the calculation the q is 1.127 into 10 to the power minus 3 into p. The value of t is also in p. okay, after that we have to calculate the resultant force, that is a 14th step, resultant shear stress, that is a qr equals to, the formula is like that, q1 square plus q2 square plus twice q1 into q2 cos theta. okay, after putting we get the value q1 square equals to 3.968 into 10 to the power minus 4 p whole square plus 1.127 into 10 to the power minus 3 p whole square plus 2 into 3.968 into 10 to the power minus 4 p, 1.2127 into 10 to the power minus 3 p. Cos theta is 0.8. So after that the resultant shear stress Fr equals to 1.464 into 10 to the power minus 3 p. The resultant force is also in p. This resultant shear stress, that is a QR, should be less than or equals to Fu upon under root 3 gamma mw. Okay, so thus QR equals to Fu upon under root 3 gamma mw. We know the value of QR, we know the value of Fu, and we also know the value of gamma m. Oh, sorry, not a W, not, it is not for the well. 1.464 into 10 to the power minus 3 into P. Fu is 410 upon under root 3 and 1.25. The value of gamma mw is 1.25. Okay, this gamma mw, this is for the shaft weld. Okay, assuming the shaft weld, that is a 1.25. After this we have to calculate the value of P, that is 129.35. After the calculation of this equation, we get P equals to 139.35 into 10 to the power 3 Newton. This is for the factored load for one bracket plate. We have to calculate for the service load. Thus, service load equals to P upon 1.5. Okay, so we know the value of P is 129.35 into 10 to the power 3 upon 1.5. After the calculation, we get a service load equals to 86.23 into 10 to the power 3 Newton upon, sorry, this is the value of service load. Okay, after that, the next step, that is the last step, that is a load taken by bracket or both bracket plate, that is a 2P equals to 2 into 129.35 into 10 to the power 3, that is 258.7 into 10 to the power 3 Newton. Okay, thank you.